Hello and welcome to my review of the Creality CR-10 3D printer, which was kindly provided to me by BangGood. It's a 3D printer which has a very big printing area, 30 by 30 by 40 centimeters. Comes in a rather large box, 63 by 52 by 27 centimeters large, and comes almost completely pre-assembled. It's quite popular lately and there's quite a few reviews on YouTube already. People say that they get it into working order within half an hour to an hour of opening it. So let's see how this will go. It was well packaged in a big box, 13.5 kilos. And the printer essentially comes in only two pieces. This part, you can see nice packaging material everywhere. This part here should be the horizontal frame. I will give you a more detailed look in a bit. And underneath, on a different layer, you can see the foam custom cut, box of tools and accessories. This here should be the main controller, which is in a metal box with just a few wires, which are nicely labeled. It contains the power supply, the display, the controller, and you'll get a better look at it in a bit. And a row of masking tape for the bed. And this is the bottom frame, which, once mounted, only a few screws will go vertically. I'm sorry, this is the vertical frame. And once mounted, this should be all the assembly the printer really needs. So, let's take a closer look at the parts. This frame has the extruder, custom extruder by Creality, which is probably a design of their own, which is a Bolden extruder. Here is the Bolden tube, a connector which supplies the power and the power to the heating head, the two fans, one to control the one to cool the extruder and one to cool the part, and the thermistor. So they're all in this connector. On the other side should be the extruder itself and the Z-axis motor. A very interesting feature of this printer that, unlike the Prusa style repra printers, it only has one Z-axis. On this side there is just 3 rollers. It uses 20 by 40 extrusions here for the vertical reels and 20 by 20 extrusions for the horizontal sides. Now let's look at the other frame. Which is the base of the printer. Heated bed, as I said, 30 by 30 centimeters X and Y, and 40 on the Z-axis. I'll cut this off. A glass bed with a heating plate underneath. It doesn't use linear slides, it uses rollers like these. I'll give you a close-up. However, it seems they achieve a pretty good precision with them. I'll place the printer on the bed now, and probably the first thing one should do is adjust these rollers. I will switch to a close-up lens for this in order for you to be able to follow. Before I go into adjusting these rollers, this box of accessories should have also all the tools required for the assembly of the printer. So we'll open this one. And let's see what it contains. Power supply cable, US style. Power supply cable, European style. Nice. This should be the end stop. And a few screws, and this should be all the screws one needs to one needs in order to put together the printer. This is the holder for the spool of filament, packing list, and very short instructions for assembling the printer. However, there is a SD card somewhere in the kit, or there should be, and on that card are much more detailed instructions for assembling it and calibrating it and using it. After sales service card, web addresses, and a bunch of barcodes. Looks like a warranty registration in Chinese and in English on the other side. Guarantee, a QC stamp, tools, a bunch of hex wrenches, a screwdriver, 2 normal wrenches, a pair of pliers, and some cable ties. I don't know what the cable ties are for, but we'll see. USB mini B cable. This is the other part of the spool holder. It will come together something like this. A small spool of filament I guess not more than 150 grams, maybe 200. A USB card reader, micro SD, and a micro SD card in there as well, I think. And on this card is where the instructions for assembling the printer should be, and there it is. It's a 8 GB SanDisk card, supposedly. You'll see. A spackle for removing the printed parts from the bed, and this one is sharpened very well in the right way. It's beveled on one edge and flat on the other, so it can be used to scrape the parts of the bed easily. Teflon Bowden tube, but there is one already on the vertical assembly, so this is a spare. A needle which is extremely sharp. This looks like an acupuncture needle to me, and it's probably intended to clean the nozzle if it gets clogged, stuck into a piece of foam so you don't prick your finger. A 0.3 nozzle. I don't know what default nozzle it comes with. I think it's a 0.4 millimeter. And these are the T-shaped brackets which are used to attach the vertical assembly to the base of the printer. That's it. So I'll clean this up and I'll show you the base and how we will adjust the rollers on it. So the first step, adjusting the 6 rollers that hold the bed to the bottom frame. The goal is to adjust the rollers in such a way that grabbing any one of them and turning it moves the frame with roughly the same resistance. Right now this one and this one do, and these two do as well, but the centered ones don't move the frame at all. The screws should be on eccentric mounts, so turning them should theoretically move them, yes. Now this started moving the frame, this is still moving it, but this became loose, so I'll back this out a bit. And let's see. Moves it, this one moves it, and this one doesn't, so I'll remove this one. And this is pretty good. The frame moves extremely smoothly, somewhat tight, but not very tight. All the rollers have ball bearings, so they should be pretty sturdy. I don't know if with time they will wear out on the extrusions, but this applies for any type of printer that uses rollers instead of linear motion slides. So let's turn this around and try moving the bed. Perfectly smooth. As you see on the top side of the printer, there are these yellow inserts. You see, but you don't see. I'm sorry. As you see, they have put yellow inserts in the grooves in the places where they're not used. They're purely cosmetic. I'll leave them in place now. I guess it's a matter of taste whether you want the printer to be entirely black or have this yellow highlights. There is a version with blue ones as well. Now I will have to attach the vertical frame to the base. I'll switch back to a wide angle. So attaching the top frame to the base, the first thing I'll do is remove the glass plate so it doesn't suffer some unfortunate fate. And this is interesting. Looks like a very large piece of masking tape for the bed, which with only 2 pieces you can cover the complete bed. I'm not a big fan of printing on masking tape, but we'll see. So, bottom frame, the heated bed, top frame, the stepper motor for the x-axis, and there is a question of how to orient things. The logical and according to the manual, which I've opened back there on the laptop, way to attach it is like this, so that the z-axis motor and the extruder are pointing towards the back, where also the stepper motor for the x-axis is. So this will be attached here. There is a piece of wrapping foil. And here is the first interesting thing I notice. The threaded rod for the z-axis is actually not attached to the coupler on the stepper motor. And the set screws are in place, but perhaps for some stability reasons, or maybe during shipping it got disconnected. Anyway, I will connect this after I attach the frame. I'm not sure if all the printers come like this, or mine is a special case. But basically, there's only 4 screws to put in place. 2 here and 2 down there. By the way, I should have shown you this. The threads are in the extrusions themselves. So the screws thread directly into the extrusion, and this should make the assembly extremely sturdy. Move the bed out of the way. Attach 1 screw just slightly, and then 1 on the bottom. there is an interesting point here. The bottom frame actually stretches the top frame a little bit in this direction, and this is what will align the Z carriage to move tightly on its extrusions. So I will not initially adjust anything on these ones until I have tightened the bottom frame to the top one, and only then will I adjust the Y, the X-axis and the Z carriage basically, if needed. Let's see. I'll switch in time lapse for a bit, so you don't have to watch me putting screws in. So the 4 screws, which are M5 by 20, which hold the bottom frame to the top frame, are in place, and the frame is already extremely sturdy. There is practically no movement possible already. It's completely stiff. However, in the kit there are 2 more T-shaped brackets which are placed here and on the other side in the same way to attach the frames together even harder. So the structure of this printer should be extremely sturdy, and this should result in usually high quality prints if the guides using the rollers are precise enough, but there will be no wobbling of the frame that I can see at this point. So I will attach these brackets. Interesting point is that on one of them is the Z end stop. Here is the switch, and of course it goes on the side of the printer where the motor for the Z-axis, as well as the motor for the X-axis, as well as the extruder are placed. So this bracket will go on this side and the plain one will go on the other side. Back to time lapse, and by the way, these are attached with typical T-nuts and screws. So back to time lapse, and then we'll see the rest. Now that the T-shaped brackets are in place, the frame of the printer is totally immovable. 4 screws hold the bracket to the vertical and horizontal extrusion, 2 screws on the bottom through the 20 by 40 into this 20 by 40, and on the other side exactly the same. So this makes for an extremely sturdy frame. The adjustment on the x-axis is almost perfect. Could probably use a little bit of adjustment, but not really. There is no wobble to speak of. As for the z-axis, it seems sturdy enough. If I move it on this side, it will wobble a bit, but I'm applying quite a bit of force, much more than it would take during usage, because it's only carrying this 20 by 20 extrusion and the extruder, which is pretty lightweight, it looks like. By the way, very nice design here. The design is nice because the GT2 belt, which moves the extruder on the x-axis, is threaded in the groove of the aluminum extrusion on the top, goes through a roller here, which I'm not sure is, yes, it is visible in the video, back here, this roller, and then goes underneath the extrusion, is mounted to the extruder there, and then the rest of the belt goes back to the stepper motor on this side. So the belt is completely hidden and not really visible during usage. Similar thing is done here for the y-axis, even though because this extrusion is 20 by 40, the belt actually rides in the middle of the extrusion and not inside the groove, but still pretty unobtrusive and not really visible, the black belt on in front of the black extrusion. So this is a nice touch in the design of the printer. Makes it look more streamlined. The next step to do would be to see why the threaded rod for the z-axis was detached, and perhaps attach it back into the stepper motor. The stepper motor, in fact, is wobbling, and one of the screws to which hold it to the extrusion is not at all tightened. Perhaps this is intentional, but I'm not sure. I'll have to take a look. So, the interesting point is that the z-axis can go all the way and toggle the limit switch with the screw sticking out from the top this much, which means that it's probably okay to have it attached in this way. I'll give you a lower point of view on the camera so that you can see how I'm going to attach it. Trying to find out whether the threaded rod for the z-axis should stick out so much. I took out this piece, which was a cap held on here, and here is what it looks like on the inside. The threaded rod is press fit into a bearing, and this plastic piece gives it a little bit of wobble, and this has a ring here, which when screwed down there will hold the z-axis. So this will allow the z-axis to be adjusted so that it is perfectly vertical, and this plastic piece is not completely tightened, so I'll tighten it. The fact that it's not tightened may be intentional, because it will allow the axis a little bit of movement to make itself parallel. So for now it looks like the left screw is completely tightened and the right one is left a little bit loose. And the two screws holding this plate I will put in place, but they will not tighten completely. And I will only do this, I will only tighten them after I attach the Z-axis to the stepper motor on the bottom. So this will allow me to make sure the Z-axis is vertical and parallel to the extrusion, otherwise there will be a tendency to bind. The carriage down there doesn't have any wiggle room whatsoever. It could not move in this direction, so as it moves vertically, if the Z-axis was not parallel to this extrusion, it will bind. So it should be allowed to move a little bit and be adjusted in the bottom and on the top, and only then I will tighten this piece. So I'll do this now in time-lapse mode. So indeed a very important point here. This is the top of the Z-axis. As you saw on the time-lapse, the threaded rod is pretty tight in the ball bearing in there, but it can be slid down. And I had to slide it down in order to attach the stepper motor on the bottom. But here, these two screws allow this plate to move in the X direction, left and right. And these two screws allow the Z-axis to move back and forth in this direction. And the only way to make the movement smooth and easy when the carriage is at the top of the Z-axis was to loosen both of these screws and both of these screws and tighten them only when the whole X carriage and the whole Z carriage was at the topmost position. And now it's very smooth and easy. It was otherwise binding even after I adjusted in this direction back to forth or parallel to the Y-axis. I still had to loosen these two screws and adjust in the left to right or the X-axis direction, and only then did I get smooth and easy motion from the bottom all the way to the from the top all the way to the bottom. You can see how easy it slides. You can even push it against the stepper motor. So this was critical, and it's important in order to get a nice smooth motion. So this completes the mechanical part of the assembly. The only remaining thing would be to attach the controller. Here is a closer look at it. Switch for the power supply to 20 and 110 volts. It is in 220 right now. Micro SD card slot, mini USB, connectors for the wires coming from the heated bed, and as you can see they're keyed, it's impossible to get them wrong, and the wire coming from the printing head. In addition, there is a set of wires coming from the back of the power supply, and there are 3 sets of wires. One is X-axis stepper motor, X-axis limit switch, extruder, so this is the extrusion motor. The second set is Y-axis, and this is Y-axis end stop and Y-axis stepper motor. And the third one, obviously, Z-axis end stop and Z-axis stepper motor. The connectors are keyed, it's impossible to flip them around the wrong way. The ones for the end stops don't matter because they're just switches, but still they're keyed and they're labeled, so it's pretty much impossible to get them wrong. And once again, what is what? Z-axis stepper motor, Z-axis limit switch on the plank here, which we assembled in the beginning. Extrusion stepper motor. Here is the X-axis stepper motor, and in there the X-axis end stop, and the Y-axis, just a second, down here the Y-axis stepper motor and the Y-axis end stop. Connecting these wires should basically complete the printer. Everything that is left after that is bed leveling, maybe a bit of calibration, and printing. So in time-lapse mode I'll connect the wires. Or I might as well connect them as you watch, because this shouldn't take more than a couple of minutes. There is nothing to it. Here is the heated bed, print head, and then Z-axis means goes down here. Probably I'm gonna need better to pass it. As I said, impossible to get the polarity wrong because they're keyed. Here is the Z-axis and stop. This side. X-axis and extruder. Here is extruder. X. The connector is at the bottom, on the bottom of the stepper motor. And the X end stop in here. And finally, Y down here, stepper motor, and then stop. That's the wiring complete in 2.5 minutes. Next, bed leveling. Put the glass on the heated bed. It's interesting that the glass is laminated in plastic on both sides, which is very nice, means it will be kept very clean until the very last moment. I will remove one side and I'll put that side down towards the heated bed. Here is so you can follow through. And I will attach it with the clips, just normal office clips. I'll turn the printer around so that the controller will go on the left and the x-axis, the y-axis faces me, and then we'll start with the bed leveling. A short note on the contents of the kit here. There were these screws, which I don't know what they'll be used for. No mention of them in the manual. The wrenches, haven't used them yet. Cable ties, probably will be useful for streamlining the cables, but I'll do that once the printer is working. The wrenches can be used for adjusting the and tightening the rollers, but I didn't have to do that. The hex keys are all there, and this screwdriver, flathead screwdriver, very cheap one. I don't know why they included it in the kit at this point. And this bag, it says spare parts, and indeed it is only spare parts. It has an extra end stop, a few T-nuts, an extra coupling for the Bowden tube, an extra screw that is used to mount the top to the bottom frame, an extra nozzle, and this is in addition to the other 0.3 nozzle that was in there. So in fact there are 3 nozzles in the kit, and that's it. There are no pieces left over for a second printer. Next part, connecting it to the computer and starting the bed leveling. In the time-lapse mode I just made sure that when the z-axis has already hit the end stop, the bed won't touch the printing head anywhere. Just to make sure that when I start moving it, it will not crash into the bed. So I will attach it to the laptop and start the bed leveling. I found out what these are for. They hold the spool holder to the electronics package, and there is just a spare one. So that mystery is solved. I realized I hadn't connected the bowden tube, which is important for the printer to function. So this goes in here, just push. So the filament spool will be on here, it will go in there. And I don't know if I'll use this one or some filament that I have lying around to test. Let's see. Here is a very important piece of advice, in my opinion. Once you start doing the bed leveling, look at the sequence in which it performs the bed leveling, or performs the homing. The head first moves left, then forward, and then the z-axis, which is fine. However, if your head happens to be here, when it starts moving towards the negative x-axis, it could hit this clip if it's all the way in. So I've pulled it out in such a way that the nozzle passes beyond it when going through here, which guarantees that if my printer is in this position for some reason and I tell it to home O-axis, it will not hit the clip during moving the x-axis. And this is important. Now I'll keep going with the leveling. So the bed leveling is almost complete. Interesting points. This printer is much noisier than any cubic Kossel I've assembled myself before and reviewed. You can see my full video with the review of it, because there is a big fan inside of the electronics unit, and also the head cooling fan, which is constantly running, is quite noisy. You can see the noise level here when the printer is running. For comparison, if I switch it off, so it's a noisy unit, especially the fan hitting the electronics. It works with repetier host, and the heating of the bed and the extruder goes pretty well. The extruder heats slower than the one I have on the Anycubic Cossel, but the heated bed is pretty decent. I've set it to heat to 55 degrees Celsius, and in less than 2 minutes it is at 49 degrees. The head has already reached 200. The next step is to slice something and try the first print. After, of course, I will re-level the bed after it has heated up, because so far I leveled it roughly without heating it. To level the bed when it's cold, it's useless. You have to have the bed temperature and the extruder temperature at your working temperatures, and then check your bed leveling before you start printing. Otherwise the chances of getting a bed first layer adhesion are pretty high. So time to try first print. I'll do something which I don't really recommend, but is worth trying at least once for fun. I'll try to print on the clear glass without anything on it. Just glass. No tape, no glue, no nothing at all. I'm trying to test the extruder. As you see, I just fed the white filament and some brown green stuff is coming out, which means this extruder was actually tested at the factory before being shipped to me. Good point, a good moment to test the extruder. It's rotating in the right direction and filament is coming out of the nozzle, which is perfect. Time to back it out a bit, which will stop it from leaking. When you're dealing with a normal Cartesian printer like this one, it's a good idea to keep your rail on the y-axis clean. It's very easy to get plastic onto it. These tiny little filaments which you produce all the time, and then it will interfere with your motion. So home it, and load the model and hit print. Nothing left to it. Let's see. This is set to print it to 20, and it should should start any moment now. Yes. Looks pretty good so far. I'll give you a low point of view. So you can watch this first print. As you can see on a perfectly clean, brand new glass, prints usually stick. The motion of the printer is not as noisy as all the fans, and it's working pretty well for now. In fact, it looks almost perfect. But let it finish this print and we'll actually see. It's interesting to watch a Cartesian printer print this object on a Delta, which I have and I have assembled. All the three towers are constantly moving even when forming a straight line, and here of course when you're moving parallel to the X or Y axis only one stepper motor is working. So it's interesting to watch, and the sound of the printer is different. But from what I can see so far, it's doing amazingly well. I'll go get my calipers while this is printing so we can measure it. It's at layer 46 of 59 at this point. It should be done any moment. and it's finished. Take it off the bed. Came off just like that. Pretty trivially. And a close-up of the part is in order. We look for layer quality. And consistency. So far, pretty much perfect. Nothing to complain of for a first print. After just bed leveling, no calibration of extrusion or anything else. The wall thickness here should be 0.8, 0.77 on this side, 0.73, 0.73. This should be 20. This is pretty much perfect. And this should be 30. And it is. The height of this object is 10, I believe. I got 11.75, but I'm not sure whether it's not actually 12 millimeters. I have to check the STL file. In fact, this object is a very nice printing test object. I'll put a link to it in the description, as well as a link to the printer, which seems to work extremely well. Again, this is a $500 printer at an amazing, for the size, price, because it can print objects which are 30 by 30, 30 in this direction, 30 in this direction, by 40 centimeters high. Look at the size of this thing. It's a pretty impressive printer. Again, extremely sturdy frame, extremely well, almost impossible to move any parts of it. Practically no setup. 1, 2, 3, 4, 5, 6 screws on this side, 6 screws on the other side. Total of 12 screws to put together. 9 wires to plug in. Completely assembled control box with nothing to it. USB port, micro SD card slot, micro SD, the connectors on the back, and that's all. It just worked. So to sum up, extremely easy assembly, 12 screws, no setup apart from bed leveling, which is very convenient because where these 4 screws are, on the bottom they're spring loaded with big knurled knobs which you can turn to adjust the 4 corners of the bed. 40 by 20 extrusions vertically, 40 by 20 here and in the center, and the rest are 20 by 20. The frame is sturdy as hell, won't move. Only one Z-axis extrusion motor Z-axis stepper motor, which doesn't seem to cause any trouble. All metal extruder, which is very good. Glass printing bed, 30 by 30 centimeters with a heated aluminum plate underneath. Heats fairly well and fast. I haven't tried anything above 55 degrees, but I have a spool of ABS and that is the next thing I should try. The control box, which is separate, could be a convenience or an inconvenience based on how you look at it. From one point of view, you can move it conveniently, put it further or closer to the printer, and it makes the printer extremely clean looking. Except, of course, this bundle of wires that goes to it, but every 3D printer has it. I haven't opened the electronics yet, which is something I want to do, and take a look inside, see how they are put together, what kind of controller board is being used on this printer. And overall, great experience. The first print, no calibration again, just bed leveling, came out perfect. Could not complain, dimensionally accurate, the layers are extremely consistent. This is sliced at 0.2 mm height and the layers are barely visible, very smooth and nice. This is comparable to the result I got from the Anycubic Cosel on my first print, which took 3.5 hours of calibrating. But calibrating a delta is harder, while a Cartesian printer is usually easier. And this one was trivial, only bed leveling. It doesn't have auto bed level feature, but if you're lucky and your glass is flat, which mine seems to be, then auto bed leveling is not necessary. All you have to do is set the 4 corners to bind a piece of paper barely, which basically sets your zero of the z-axis at 0.1 mm roughly, and that's all. After you've set the 4 corners, you can verify the center. Mine was within tolerance, and that's all. Bowden extruder. In fact, this in my opinion is an advantage because it makes the head lighter. The classic wrap style, like Prusa i3 printers, carry the extruder motor on the head, which makes it heavier, which means accelerations have to be slower, and which slows down the print. I haven't tried to push this to faster than default speeds, but I think it will be able to manage to some extent because of the very sturdy frame and the lightweight head helped by the Bowden extruder. The extruder itself is direct drive. On the stepper axis, on the stepper motor axis, there is a narrowed gear, and on the other side is a ball bearing with a roll arm which pinches the filament spring. You just squeeze like this to release it. Very easy to load the filament. This holder is convenient, I like it. However, it fixes the position of your electronics box compared to the printer, at least in the x-axis direction. Y-axis direction. You can move it in the X further or closer as you wish. Overall, very good impression. If I hadn't shot video, I would probably be done on printing with this in less than an hour. You have seen in real time almost everything I did to assemble it. It was mostly assembled, calibrated and start printing. Overall, great impression. It's not surprising that so many reviewers are saying this is one of the best printers for the price. Thanks for BangGood for sending it to me to review, and have a good day. Watch my other video if you want to see how a Delta is put together. Thank you.